name is Ronit Avadhuta, and today we're going to figure out how to break apart integrals into fractions so that they're easier to integrate, and it's going to be a very helpful tool so that you don't have to spend more time on integration or have to use a calculator. You can just simplify lots of integrals using this method. So what does it mean if I break an integral into different fractions? Let me use an example. So if we have the integral of 1 over, let's say, some polynomial like x squared plus 3x plus 2 with respect dx, of course. Now, note the first thing that the bottom is really easily factored. So we can really easily factor this into something called like x plus 2 times x plus 1. And if we FOIL, these two terms are going to be x squared. Yeah, it's x, 2x, and then finally plus 2 at the end. So we know that. And we can really represent the term inside as some numerator over ax plus 2. And we're going to add b over the x plus 1. And we know that in the end of the day, we have to get the polynomial that we have from before. And we have to have 1 on top. Well, what we can do is we can multiply these, and we can multiply these, and then what we essentially get in the numerator is no longer a and b, but we get a times x plus 1, and then we have b times x plus 2. And between both these, we're going to have an addition because it's going to be same sign. And in the denominators, we're still going to have just the polynomial now. So the question is now, what does this tell us? We want to get this numerator, these a and these b's, we want them to reach some value so that we eventually get a 1 over here. Now, this looks pretty good because we actually have an x plus 2 and we have an x plus 1. So just logically thinking, so x plus 2 minus the, in parentheses, x plus 1 would just be 1. So we can say, if I use this color, let's say a is our -1 and b is just our 1. Cool. So now we found out, okay, what we have here and here. So now we've all done all this hard work. Let's apply it to the problem we have at hand. So applying it to the problem we have at hand, we're going to get that this integral can be, remember we had a -1 over this x plus 2 part. And then we're going to add it to the x plus 1. Now, remember that if we have just the general integral of 1 over x with respect to dx, this is just going to be natural log of x. What we can do is let's take out this negative. So let's turn this into a plus and move this negative over here. And let's realize that, okay, this is going to be natural log of x plus 2. And then this over here, this is going to be natural log of x plus 1. Now, what we can see is because we had the subtraction, we know that we just had to divide the two. Therefore, what we're going to end up at the end is just remember this ln and this ln of x plus 2 and this ln of x plus 1. What we're going to end up with at the very end is just going to be a negative ln of x plus 2 over x plus 1. And don't forget the plus c at the end. And then the question is, okay, let's try another example. What if instead of a 1 in the numerator, it was a little bit more complicated? Let's say we had x. Actually, no, let's say we had something like 5. Well, you have to realize in this case, the fractions actually work out really nicely because you can divide what's ever inside by 5. So it would be just 1, and then you can move the 5 outside, and you can still use whatever answer you got from before. And yeah, thank you for coming, learning about how to do integration using fractions, and I hope you learned something today.